Welcome to the Generative AI in the Real World podcast. Today we have Robert Nishihara, co-creator of Ray and co-founder of Anyscale. So Robert, welcome to the podcast.
Thank you so much. Good to see you again.
So we'll talk obviously about Ray. And for people who are not familiar, Ray is an open source project that came out of Berkeley that has become kind of like the default AI compute engine, the default foundation layer. And I've been writing about Ray for many years, and recently I wrote a series of posts about how I was observing companies building custom AI platforms, and a common substrate seemed to be Ray across many companies. But the reason I bring this up is because Robert then has a great perch because he gets to work with a lot of companies that are on the cutting edge of AI, but are also tackling some of the hardest problems in AI. So I wanted to pick his brain about some key AI trends. So the first thing is about data. Okay, so we hear about that people are running out of data. The teams training these foundation models are running about data, but then also that the data tools themselves are lacking because everyone is focused on training and not enough on the data tool. So give us, Robert, kind of your high level view of the state of affairs as far as data in AI.
Yeah, well, the importance of data in AI is something that, of course, many people have identified and have known for a while. But this is actually a really big paradigm shift in how the field of machine learning has been thinking about AI. And if you go back a decade to the ImageNet benchmark, ImageNet is one of the famous computer vision benchmarks where you have tons of images and you try to build models that can classify the images into different categories like cars, cats, dogs, trees, and so on. And a huge amount, if you think about the progress that this benchmark drove in AI, this benchmark really drove progress in computer vision and all of AI for a long period of time. And all of the innovation in this benchmark was really around building better model architectures, trying to innovate on the optimization algorithms to take your ImageNet data set, train a model, and ultimately do better on object recognition. But the interesting thing was that in this benchmark, the data set was considered static, right? You take your ImageNet data set, you split it into your train and test data, then you train your model, and all the innovation is on the model architecture. Now, we're in a different paradigm where, the model architecture is not completely static. There's still innovation there, but it's more transformers are very common. There are a few standard model architectures at this point. The optimization algorithm is much more static. Like we are all using variations of stochastic gradient descent. And where all of the innovation is happening is on the data side. It's like acquiring different sources of data, evaluating which sources of data make sense to train the model on, curating the data, generating synthetic data, like extracting, filtering out low quality data. So I actually think that, especially given how we know how important the quality of the training data is to impact the quality of the resulting model. And the way people are thinking about curating training data and acquiring training data has really shifted over the years. So if back to ImageNet, the kind of data preparation or processing that people did was very limited. You might crop the images, you might scale the images to try to generate, to augment your data set. Now you're using AI to really process and curate the data. That's the big shift. So for example, imagine you're working with a bunch of video data, right? You want to filter out low quality data. How do you do that? That's an AI task, right? To determine or you're working with an autonomous vehicle company, right? You have self-driving cars. They have hundreds, millions of miles of driving, tons of video footage, and you're trying to find the most interesting data to train on. A lot of the data might just be driving down an empty road for a long stretch of time, nothing interesting happening. Some of the data is a pedestrian doing some crazy thing, something you've never seen before. That is, not all data is created equal, right? Some data is far more informative or valuable than others. And so a lot of the process is taking all of your data and extracting the most informative, most interesting, highest quality data to train on. And that is very much an AI task. There's a lot here.
And Robert, for the most part, a lot of the tools, at least in the resurgence of data engineering tools 5 years ago, which was centered around pipelines and orchestration tools for structured data, mainly aimed at warehouses and lakehouses, right? So now we have unstructured data, but increasingly, as you point out, multimodal data.
Yes.
So uh, what what's the challenge as far as the tooling around working with that same data and trying to do the same sorts of data processing and data prep that people are accustomed to?
Lots of companies have lots of data, right? And they've acquired all of this data and they're storing all of this data because they believe they can get insights out of the data, right? They want to get value out of it. They want to make decisions. And the way they get value out of the data today is by running SQL queries. They'll run SQL queries, they'll run some simple analytics to learn about their data and to explore it
For structured data.
for structured data, right? And because not because they don't have unstructured data, but because you can't really touch that with your SQL queries. Your SQL queries are not going to operate on PDFs or on videos or images or, arbitrary text document. But the reality is that what you can do with SQL queries is quite limited, right? The amount of insight you can get. If I compare, imagine I'm a company and I'm trying to get insight about my sales pipeline, right? The kind of SQL queries that are easy to run are things like asking about which companies have been in certain stages of the pipeline for what certain durations, pre-built fields and categories that I've already thought about. But all of the insight is in the notes that the sales representatives are taking, in the videos of the recorded meeting calls, all of these kinds of things. And you're not getting any value out of that today. So I think the way that people will get insights out of data in the future is with AI. Right? They'll have AI read the data, reason about it, and draw conclusions. And that is a very different paradigm. So I imagine data processing shifting from really being a SQL centric workload to an AI centric workload. And if it's an AI centric workload, it's going to be a GPU centric workload, or perhaps mixed CPU and GPU workload. And the tooling around workloads that are very GPU and AI intensive and very data intensive is practically non-existent, right? Or it's very immature, this tooling for multimodal data processing. So that's a challenge.
Yeah, because in a future pipeline, you can imagine. I'll throw out a few examples here, right? So I have a piece of text, and then I remove personally identifying information. Then I correct grammatical errors or translate foreign terms, and then I embed. Right. So there's like this complicated pipeline that is not really going to be addressed by kind of the data engineering tools from the structured world, right?
Yes, you're going to have to use AI to do that task that you just described.
So as I mentioned, just to close, right? So as I mentioned, you have a unique perch in that Ray is actually the foundation for many of the AI platforms that these leading edge companies are using, including the companies building some of the foundation models we've come to love and use. So, w- can you share some of the things you're hearing? So, what should we expect in 2025? Better reasoning, multi agent architecture. So, what are you excited about?
Well, all of those things you mentioned, I think reasoning capabilities will be far better. I think just specifically, one benchmark of reasoning is math. And I think there's a huge amount of interest in and promise in building models that are really good at doing math. Multimodality, like you mentioned, will be ubiquitous. Like this is something that's today, most of us are using text based models, right? Text input, text output, but multimodal models, at least text and image, is going to be ubiquitous. I think you covered a lot of ground with the data side of things. People are going to be using AI across the board to get insights out of data, out of types of data that they didn't have a way to use before, that was just sitting there. And companies are going to find they have a lot of internal data, documents, design documents, recorded Zoom calls that they weren't doing anything with before, that they assumed had no value, that actually have huge amounts of value. And that's just internal stuff. I think the amount of energy and money that people spend on curating data, on data processing and data preparation is going to explode. Far more than actually the amount of there will be a lot of training, but it's going to explode far more than the amount of money and energy people are spending on training. There's a lot to look forward to. A very few companies will do the pre-train the very largest models. I think many companies will train lots of smaller models, and lots of companies will do post training, like you said. I think a lot of the quality or what we really like about a lot of the foundation models that we use can be attributed to the post training stage, which, like you said, is quite complex, and there's growing complexity around post training.
So a year from now, exactly 12 months from now, the foundation models will be much better, I hope. What do you think?
I believe so.
Okay.
I
And with
hope
that,
so.
thank you, Robert.
Thank you so much.
Thanks for listening to this episode of the O'Reilly Podcast, Generative AI in the Real World. If you want to listen to the full version, please log in to the platform at O'Reilly.com.